So we're going to be working with inequalities. You might recall the last time we said inequality must have a less than or a greater than, less than equal to, greater than or equal to, strict less than or strict greater than. And we have a method that I call the cut point method, which will solve any type of inequality. I believe y'all all have this sequence of steps that I've passed out. So let me go ahead and write down the first problem we're doing today. We're going to do problem number 3 on homework assignment 7. Okay. So this is problem 3. X times x minus 1 is problem 3. X times x minus 1 is less than or equal to 20. And this is on homework 7. Still seems like such a new semester, but I guess this is the 4th week. So x times x minus 1 less than or equal to 20. I believe I mentioned the last time. Notice how it never says anything about cut points. You've just got to know. If it says something about solving an inequality, or if the instructions just said solve and there was a less than or greater than in it, then that's when you follow that sequence steps for the cut point method. Okay? So we'll start off by rewriting the inequality as an equation. So that's step 1. We're finding what I call the solution cut points. Solution cut points. We're going to solve x times x minus 1 equals 20. Okay. So replace the inequality with an equals and solve for x. These numbers are called solution cut points. Well, how the heck am I going to solve this for x? Well, first of all, I need to distribute that x. So we'd have x squared minus x equals 20. And once I do that, what type of equation do we have? It's a quadratic equation. So get a 0 on one side and either factor or use the quadratic formula. I'd factor it if I were you. So I'm going to move the 20 over. So we'd have x squared minus x minus 20 equals 0. I've mentioned before the way with algebra it just keeps building. Okay, we factored earlier this semester, then we solved quadratic equations by factoring. Let's see, this is one that's going to be pretty easy to factor. How do I determine if ones are pretty easy? Well, if there's not a number in front of the x squared. That means I'm just going to have to put x and x. And for 20, 1 times 20, 2 times 10, or 4 times 5? 4 and 5? Now that 20 here is negative. The second sign is negative. So what do we say that means about these signs here? There's a positive and a negative. How should I arrange them in order to get a negative x for the middle term? Negative 5 and positive 4. Did y'all hear that? Any questions? Now set each one of these factors to 0. And we get x equals negative 4. And x equals, is that going to be a positive 5? Now these are cut points, which means we're going to label them on a number line with either an open or closed circle. How are we going to label them? Well, on step 1, if there's an equal sign, you'll use a closed circle. If there isn't, you'll use an open circle. So let's see, what do we have? Yeah, there's an equal sign on it. So we're going to have a closed circle for those. Those are the solution cut points. There's two types of cut points. Solution cut points and denominator cut points. Step 2 says, okay, take any denominators and say they can't be 0. I believe last week, maybe a week ago, right now, I was doing stuff about denominators can't be 0 in a rational expression. Okay? Well, we call those denominator cut points. But over here on this particular problem, there are no denominator cut points. Why? Well, there's no fractions. So, problems 1, 2, 3, I think the first 3 problems in your homework have no denominator cut points. You should be able to look and tell if there's denominator cut points, depending on whether or not there's fractions in the problem. So, let me draw my number line. Make sure you label those cut points in numerical order. Well, here it's not too difficult to get them in numerical order because one of them's negative and one of them's positive. The negative number is always going to be to the left, isn't it? Okay. So where are we on this sequence of steps? What have we done? Well, we've done step 1. We found the solution cut points. We've done step 2, the denominator cut points. We've done step 3. We've drawn the number line and labeled the cut points. So step 4, you're going to select a number from each interval. But for our purposes, it doesn't really need to be from each interval. Here's how I look at these things and decide, will they alternate? Okay? If there are only linear equations, if you don't have to factor anything, then it alternates. Okay? Now, if you have to factor it, like over here we had to do some factoring. Okay? If there are repeated factors, then it might not alternate. Might not alternate, which means you would need to check all 3 of these. What do I mean by repeated factors? If up here, when we were factoring with this trial and error, if we wound up with the exact same thing in both sets of parentheses, like instead of an x plus 4 and an x plus 5, if we'd had x plus 4 and x plus 4, then okay, it might not alternate. Okay? For y'all's purposes, it alternates. So, you don't really need to test every interval, just one of them. And what I normally do, if 0 isn't a cut point, that's the one I choose. Where would 0 lie on this number line? Does it lie between negative infinity and negative 4, between negative 4 and 5, or between 5 and infinity? Negative 4 and 5. 0 always lies between a negative and a positive. So, moving up here, I'm testing this middle interval. If I get a true for this statement, I'll get false and false for the other ones. Okay? If I get a false one here, then I'll put true, true for the others. Okay? So when I test the interval, I have to plug it into the original statement of the problem. So, maybe I zoomed in too much. I'm going to have to put a 0 in for this x and that x. So I'd have this, 0, parentheses, 0 minus 1 is less than or equal to 20. Well, the 0 minus 1 is a negative 1. It's times 0. Anything times 0 is 0. if I plug a 0 in right here and here, can y'all do that in your head? Sometimes students tell me, I don't need to write that out. This is just my thought process. Your goal is different from my goal. Your goal is to get the answer as quickly, the correct answer, as quickly as possible. So when I plug a 0 in up here, let's see, what are we getting? We'd have a 0 is less than or equal to 20, true or false? That is true. So that means shade the true ones, cross out the false ones. Okay? Are y'all caught up with me? The last step is that interval notation. Express the shaded interval using interval notation. Remember, use brackets for closed circles and parentheses for open. So what will my answer look like that I'm going to type in? I'll go bracket, -4, comma, 5, bracket. That's what I will have to type in there. Okay. Any questions on how I tested that? Y'all agree with that? Y'all follow what I did? Plugging a 0 in here and here. We'd have a 0 times 0 minus 1, which is -1. -1 times 0 is 0. So 0 less than or equal to 20 is true. It's not equal to 20, but it's sure less than. So let me pull up the problem and type in. What is it? A bracket, -4, comma, 5, bracket. Ooh. Check answers right here. Okay. Any questions on that? Problems 1, 2, 3, or let's do number 2. Okay. Let's do problem number 2 now. Will there be any denominator cut points on number 2? Are we going to have any denominator cut points here? No, because there's no denominators. Okay. Did I see a hand go up? Are there any questions? Are you ready to try this one? Let me write it down. This is problem 2 on homework 7. 3x squared plus 7x is less than or equal to 6. You notice the instructions. It doesn't say anything about cut point method. It does say interval notation, though. And it says solve inequality. Okay. So let me see. Let me lower this. It's problem number 2. Well, start off by finding the solution cut points. That's when you replace the less than or greater than with an equal sign. So you're writing this as just an equation. And move the 6 over. Is this another quadratic equation? Yeah, it's a quadratic equation. So we'd have 3x squared plus 7x minus 6 equals 0. It's not one of those that's real easy to solve because there's a number in front of the x squared. That 3 is there. So let's see. Numbers that multiply together to give 3. That's 1 and 3. Numbers that multiply together to give 6. 1 times 6 or 2 times 3. Let me draw my 2 sets of parentheses. Well, there's not any, possibilities other than 1 and 3, so I'll put 1x and 3x. And I think I'm going to pair it with the 2 and 3 first. If you want to try the 1 and 6, okay. I think I'm going to use the 2 and 3. And remember, if you're factoring this stuff correctly, there shouldn't be any common factors. Which means I can't have the 3 right there, because you can't have, if you have the 2 of the same number, then you certainly have a common factor other than 1. Every two numbers have a common factor of 1. So I'll try 2 and 3, like that. And can y'all do the, let's see, that would be a 9x, a 2x, I want a positive 7x. Can I arrange my sign to get a positive 7x? I think so. If we made the 9 positive and the 2 negative, that would mean put a plus in front of the 3 and a minus in front of the 2. Did I factor that correctly? Now, let's see. So, what did we decide? Did I factor it right? It's 3x squared, then a minus 2x and a plus 9x sure gives us a plus 7x. And then positive 3 times negative 2 is negative 6. Yeah, so it's factored correctly. Now I'll set each one of these factors to 0, and we get a negative 3, and I think this one's going to be a fraction, isn't it? Move the 2 over, and divide by 3, 2 over 3. Are y'all caught up with me? Now, let's see. Do y'all remember how we decide between open and closed circle? You look at the symbol. Okay? If there's an equal sign, it's a closed circle. And you can sort of remember that because an equal sign, you're using more ink. You have to write that equal sign. So use the circle that uses more ink. Here, when there's not an equal sign, you're using less ink to write it. So use the circle that uses less ink. So let's see, what are we doing here? This one's going to be it's another closed circle on both of them. Okay. There's no denominator cut point. How do I know that? Well, there's no denominators. So I think I'll do it right up here so I don't wind up cutting stuff off. Draw my number line. Have to plot a negative 3 and a positive 2/3. Negative 3, positive 2/3 with closed circles. Now, I look at it and I wonder, does it alternate? Well, I look at the factors. We factored it and there weren't the same factor in both sets. So, yeah, it alternates. For y'all's purpose, it alternates. Okay? So, I'm going to test 0. Where would 0 lie on this number line? Between negative 3 and positive 2 over 3. So right here I'm testing 0. And I plug a 0 in here and here. So that's what I'm doing. I'm plugging a 0 in to the original problem. So 0 squared is 0 times 3 is 0. Plus 7 times 0 is 0. It's less than or equal to 6. Is that true? 0 is less than or equal to 6. Yeah, that one's true. I'll shade it and cross out. Write your final answer in interval notation. -3, 2/3. Been doing this so long, but something stand out in my mind. The time the student said when factoring, I was just making it work out. Yes, that's a brilliant statement. Then there was another time when I was doing a problem like this, and a student was calling out the answers, plugging in the 0 here and here. 376. No. I tried to figure out, well, it took me a long time to figure out what the heck was he doing. Plugging in a 0 right here and here, how is he getting 376? I felt so ignorant once I realized what he was doing. 0 squared, he put a 0, 0, so there was 300. He put a 0 right here, 7, 0, so it was 370, that's what he was getting. 370 is less than or equal to 6. You know, I feel so stupid. It took me a long time to figure out what was he doing, where is he getting those weird numbers he's calling out. Okay? So, yes. On the graph? No, I mean just the tests are just going to have the intervals written out there on the paper test. Okay? So, you want to put the brackets on the graph like this? Yeah, well, I usually do one or the other, and my habit is to use the closed circles on the graph. Okay? I think there is an example, or one of the problems later on, it's going to show the graph, and it's going to put the brackets instead of closed circles. I prefer open and closed circles, but, you know, okay, so what you do, sort of up to you. Oh, let me punch it in, make sure it's right.
So the signs on the original problem are going to be closed circle.
Yes, for the solution cut points. For the denominator cut points, it'll always be open circles.
Can you put 2/3 in front of -3?
No. For this stuff here, for interval notation, it must appear in the same order that you see it on the number line. Okay? That's such a good question. I'm going to see what happens. Oh, let me just erase this. Suppose we had written the 2/3 before the -3. And I say check it. Oh, wrong. It doesn't know what you did wrong, but it's this. The numbers in interval notation have to be in the order that you see them on the number line. Like that. -3, 2/3. Okay. Another question? First time I ever saw this, the teacher's method was think about it. Let me tell you, just thinking about it and coming up with those answers is a much more difficult thing than actually following this sequence of steps. As a student, the first time I ever saw this sequence of steps, I thought, this is great. Okay? Wow. Why didn't she tell us that, show us that, instead of telling us think about it? Once I was a teacher, it dawned on me what was going on. She didn't know how to do it. And so, you're writing problems 6 down. Now this one is going to be involved. Is that a z? Okay. Z over z minus 7 is greater than or equal to 2z. Is there going to be a denominator cut point on this one? Yes. Okay, how do I know? Well, there's a denominator. So, I'm going to start off with my finding my solution cut point. That's always my habit. If you're a view and example person, on the view and example, they start off, they never use the word cut point. Oh, it looks like on this one they were doing the denominator cut points first. Okay? But I always do the solution cut point first. The order in which you find them doesn't really matter. But over the years, I always find solution cut points first. So I'm solving z over z minus 7 equals 2z. I'm going to rewrite that 2z is 2z over 1. Oh! How to make a good impression. Never too late to make a bad impression. Okay? I'm going to modify the book I'm writing. Instead of how to make a good first impression, it's going to be a whole series. How to make a good impression. So, I'll write that 2z is 2z over 1. Y'all can sort of figure out, what am I going to do to solve this equation? Cross multiply. So I would have 2, and that's going to be a z squared minus 14z equals just a z. I think I'll write it as 1z for illustration purposes. And this is another quadratic equation. So we need a 0 on one side. So I'm going to move this 1z over by, what am I doing? Am I subtracting 1z from it? So I'd have 2z squared. What's this going to be? Is that going to be a minus 15z equals 0? And this is a good one to do because it's the first time, I think, the first time this semester that we factored a quadratic equation where there's not that constant term. Like over here, there's always that constant term. Minus 6. Over here on this one we did, what was that constant term? The minus 20. What if you just have the variable terms like this one? And those are the easy ones to factor. Okay, if there's not that constant term, all you have to do is factor out one of these variables. Let's factor out a z. Well, I hope y'all can tell my z's from my 2's. If I factored a z out of each of these terms, I'd have a 2z in the parentheses minus what? What would I write here? Do y'all remember factoring out variables somewhere along your algebraic life? Would this be a minus, would it be 15? It's called factoring out a variable. If I distribute that variable, I'd have 2z squared and a minus 15z. Any questions on what I just did there, factoring that variable out? How do you know when to do that? When there's not a constant term. If there were a third term, just a number here, that's when you have to draw the two sets of parentheses and the trial and error. Where there's not that number and you just factor the variable out, that's actually easier. But it is a little tricky. When you factor out the variable, you still got to set each factor to 0, including that one there. So when I set z to 0, that's one of the cut points. Then I set 2z minus 15 to 0. Now isolate the z. What would I do? I would move the 15 over and divide by 2. The thing that's tricky here is that 0 is a cut point. A lot of times students will get the 15 over 2, but forget, you're setting every factor equal to 0. Okay, and that z is certainly a factor. So let's look at the signs up here and decide open or closed circle. What's it going to be? Closed. There's an equal sign. Now, right up here, I'm going to find the denominator cut point. The denominator can't be 0. It can be anything else. It can't be 0. Isolate the z. So I think this is going to be one where there's 3 cut points. Most of the time there's only 2, but on this one I'm thinking there's 3. Even though I'm not looking at that sequence of steps, I'm seeing it in my head. So if you want to look at it, denominator can't be 0, solve for, well, in this case, z. Always label denominator cut points with an open circle. So this is always, you don't look at the symbol for the denominator cut point. Always open circles. So we have 3 cut points that we have to test, or that we have to label on the number line. Make sure you're labeling them in numerical order. It can be a little tricky because that 15 over 2 is a fraction. So just to make sure I'm punching or labeling it correctly on the number line, pardon me, you might want to do this. If you can't, maybe you want to just think of it as 7.5. 7.5, 15 over 2. I'm not going to label, or I'm not going to write it as 7.5, but that'll help me figure out where to put it on the number line. If I draw my number line, I'm going to put 3 marks. Why 3? Because there's 3 cut points. Here's my negative infinity, positive infinity. How do I label these? The cut points are 0, 15 over 2, which is 7.5, and 7. Which one is the one I'm to the left? What's this one? 0, okay, that's the smallest. Then what's the next one? Is it going to be 15 over 2 or 7? 7. Because 15 over 2 is 7.5, so it's bigger. And let me get these circles right. 0 and 15 over 2 had closed circle. The 7 had an open circle. Now you can't test you can't test 0 here. Why? Because it's a cut point. So you're going to have to choose another number to use as a cut point. Let's see. Excuse me, as a test point. What number do we want to use as a test point? Well, we can't use 0. It's a cut point. We can't use 7. We can't use a cut point to test. Okay? Like on this one over here, you couldn't have used negative 4 or 5 to test. You can't test the cut points. So choose any number other than 0, 7, or 7.5. How about a 1? Okay. Where would 1 lie? It's right between the 0 and 7. So this is the interval I'm testing. I'm testing the number 1. You can test whatever number you want as long as it's not 0, 7, or 7.5. You cannot test cut points. So I'm going to plug a 1 in up here. In place of the z, I'd have a 1 on top. 1 minus 7 is a negative 6. Is greater than or equal. 2 times 1 is 2. So 1 over negative 6. Is that bigger than 2? Than a positive 2? That's a false statement. This is a negative 1/6 here. Okay? A negative number can never be bigger than a positive. Y'all agree with false here, which means cross that one out. Ooh, we have a lot of these. You shade this one. You shade here. You cross that out. This one you sort of begin to see what I meant when the teacher or the thing was think about it. Oh my gosh. How the heck were we supposed to think about it and come up with what answer? Parentheses, negative infinity, comma, 0, bracket, a union symbol meaning you're on the same number line, parentheses 7, comma, 15 over 2. Ooh, I messed up. It's not parentheses, it should be a square bracket there. So it can be sort of lengthy, but things could always be worse. If you were just having to think about this, how long do you think it would take you to come up with that? For the life of me, I don't really remember how we came up with the right answers back then. Just thinking about it. Parentheses, negative, infinity, comma, 0, square bracket, union, parentheses 7, comma, 15 over 2. Don't do what I just did. It's going to count it wrong, probably. What's wrong about it? Well, that parenthesis should not be down in the bottom of the fraction. It doesn't know what's wrong. All it knows is, oh, that's not what they're programmed to expect. The parentheses should be there at the end. A bracket. Oh, I put parentheses. Even if I put a bracket down there, it'd count it wrong. There. See? If I put the bracket there, bracket has to come over there. Oh. I'll just say check. Okay. Any questions on this one? Oh. This is about as involved as it gets. Okay. Now, it just dawned on me, I think I closed up something that I wanted to keep up. Earlier I showed you how I'm posting the class lecture notes. The last time, before we started this interval notation, we were doing absolute value equations. And that's when you go equal positive, equal negative. Do y'all remember that? Okay. Equal positive, equal negative. And the absolute value bars have to be isolated before you do anything else. Before you do the equal positive, equal negative. Does that sound familiar? The equal positive, equal negative? Can I coerce y'all into sort of thinking you remember it from not a week ago. It was on Wednesday. Okay? So, looking at problem number 7. Is it a cut point problem? Well, does it say solve inequality and does it have a less than or greater than? Yes. That means that little cut point method will work for it. If you're a view and example type of person, for the remainder of the problems here, I wouldn't look at view and example. Okay? Because they're going to be doing it different. They give some little rules for you to memorize, to work the ones that have absolute values in it. And then those rules sort of fall apart by the time you get to problem 11 and 12. Okay? So it's pretty easy to do the equal positive, equal negative. Y'all agree with that? Let me see. This equal positive, equal negative, I didn't get the feeling that y'all were thinking it was too hard here. So that's how we're going to find the solution cut points on this problem right here. Let me write it down. This is problem number 7 on homework 7. It says absolute value of 2y minus 5 is greater than or equal to 12. Absolute value, that's not a 12y minus 51, by the way. Absolute value of 2y minus 5 is greater than or equal to 12. Well, put this up a little more. How do I know I have to use, or I should use the cut point method on this one? Well, there's an inequality in it, okay? There's a less than or a greater than. If it says solve and there's a less than or greater than, this method will solve anything, okay? Even absolute value inequalities. Now, if you want to look at the following, view an example and learn some other ways that sometimes work, then okay, but this way will always work. Well, first, is there a denominator here in problem 7? Are there any denominator cut points? No, there are no denominator cut points. So we're just going to find the solution cut points. And how do we find the solution cut points? With the absolute value equation. This one equals, take what's inside, go equal positive, equal negative. Okay? So for the absolute value inequalities, just go equal positive, equal negative. That's how you're getting the solution cut points. There aren't any denominator cut points. How do I know? There's no fraction there. So let's see, how would I isolate the y? I would move the 5 over by adding it. 12 plus 5, 17. Divide by 2, 17 over 2, and move the 5 over, so that's a negative 7 over 2, negative 7 over 2. So if it's an inequality that has absolute values, go do what we did the last time. Equal positive, equal negative. Those are the easy ones to find, those cut points. And I haven't asked this, I should. Will there be an open or closed circle at these numbers? Closed. There's an equal sign on the symbol, so closed circle. Oh, my black pen is dead. Right here and here. Oh, let me go ahead and label the infinities. And let's see, make sure you're labeling these numbers in numerical order. Which one should be closer to the negative infinity I just wrote? Negative 7 over 2. And right here, positive 17 over 2. Are y'all caught up with me? Go equal positive, equal negative for the absolute value equations. And then go ahead and test a number. Here there's only 2 numbers you can't use as test points. What are they? Negative 7 over 2 and positive 17 over 2. Why the heck would you want to use those? What test number am I going to use? 0. And where would 0 lie on a number line? Does it lie between 2 negatives? Between a negative and a positive? Or between 2 positives? always between a negative and a positive. So this is where 0 is. So plugging 0 in to the original problem. We have the red absolute value bars. Now be careful. Don't say 15. What are we going to get when we plug that 0 in? 2 times 0 is 0. Minus 5 would just be a negative 5. And now, before you decide true or false, actually take the absolute value. The absolute value of negative 5 is what? 5. So 5 is greater than or equal to 12, true or false? That's false. Oh, I was about to say false. So I'll X that out, shade these, and here's the thing I'll have to type in. Parentheses, negative infinity, comma, negative 7 over 2 bracket, union, bracket, 17 over 2, comma, infinity. Okay, so that's the thing I'm typing in. Let's see. Over here. Parentheses. Let me see if I can get it typed in on the first try without any mistakes. Comma, negative 7 over 2. I'll hit the right arrow before I put the bracket. Then union, bracket, 17 over 2, right arrow, comma, infinity, where's that infinity symbol? Right there, and parentheses. Can y'all tell that the bracket is a little bit sharper point than the big parentheses? Hopefully you can tell this is a parenthesis and this is a bracket. Any questions over that? Let's try number 9. This is going to require that you remember something that we said the last time when we were solving these absolute value equations. You've got to always isolate those absolute values first. It doesn't matter whether it's an equation or an inequality. The absolute value bars should be isolated before we do anything. So let me look at problem 1 we're about to do. What am I going to do first on this one? Move that 11. Get that 11 out of the way. Let me write it down. This is problem 9 on homework 7. Absolute value of 3x plus 6 minus 11 is less than negative 2. I hope that doesn't look like 13x plus 61. Absolute value of 3x plus 6 minus 11 is less than negative 2. Well, it's only one correct first step, and that's to get these absolute value bars by themselves. Don't jump into equal 2, equal negative 2, or something like that. No. You've got to move that 11 first. So what are we going to have over here? Will it be a 9? And on the right, we have absolute value of 3x plus 6 is less than 9. Well, at this point, have we made that problem be basically the same thing as this one over here? Yeah, it's absolute value with a less than or greater than. So are we ready to do equal positive, equal negative? Yeah, that's how you find the solution cut points. Go equal positive 9 and equal negative 9. So I'll move the 6 over. Let's see, 9 minus 6, is that going to be a 3 over here? And then divide by 3. So the first cut point I'm getting there is a 1. And what about the other one? I'll move the 6 over. So we have negative 9 and a minus 6. Is that a negative 15? And then divide by 3. Am I getting a negative 5? Do y'all agree with 1 and negative 5 for the cut points? So let's decide between open and closed circles. What are we going to use? Okay, there's not an equal sign, so it's going to be open circle on each of those. Draw my number line. And these, here, it's not too difficult to label them, are they? Because one of them's a positive number and one of them's a negative. So the negative 5 is going to be the one on the left and the positive 1 on the right. Now, realize once you've isolated those absolute values, you're through with this statement here. Okay? You're no longer using that one, you're using this one. I just realized I shouldn't have marked that out like that. It's going to look bad on the PDF when I scan it, but okay. What test number do you think I'm going to use? 0? Yeah, I can use 0. Now, where does 0 lie? Between two negatives? Between a negative and a positive? Or between two positives? Yeah, right out there. That's where 0 is. So I'm going to plug 0 into this statement right here. Don't say 36. The 3 times 0 is 0. Plus 6 would just be a 6. Now, before we actually take the decide true or false, take the absolute value of 6. The absolute value of 6 is still 6. True or false? 6 is less than 9. True. So am I going to have to write any of those union symbols in my answer? No. It's just parentheses, negative 5, comma, 1 parentheses. Okay. Come over here and type it in. Parentheses, negative 5, comma, 1, close parentheses. Okay. Any questions there? To solve these absolute value inequalities, you've got to go the equal, or that's sure how you should go about it. Make sure they're isolated, and then go equal positive, equal negative. If you want to see another way, look at view an example.
The 6 had been a negative 6.
If the 6 had been a negative 6, right here, yes, you would have changed it to, if this had been a negative 6, you would have gone plus 6 plus 6. Okay? Is this where, right here what I'm writing? Is that where you're referring? Oh, wait. Oh, gosh. There, sorry. Like right here, is that it? This plus 6? Oh, wait, no. At the very bottom. Oh, wait. If this had been a negative 6, it'd still be a 6. The absolute value of a negative number is a positive number. Okay, so it was here that we were talking about. Okay? Let's see. Like right here, there was a negative. The absolute value of a negative 5 is 5. But the absolute value of a positive is still that positive number. Okay? Another question? I want to do one more example and then we'll take our break. So we might be taking our break closer to 9:30. Okay? So I'm going to do problem number 12. And don't panic too much when you see it. First of all, is it an equal positive, equal negative problem? How do I know when I do the equal positive, equal negative? Yeah, the absolute value bars. If there's no absolute value bars, don't go back to problems 1, 2, 3, 4, 5 and start going equal positive, equal negative. Starting with 7, I believe, is where you saw the first absolute value. And that's when you go equal positive, equal negative. So let me write this problem down, number 12. Absolute value of x squared plus 2x minus 28 is greater than 20. X squared plus 2x minus 28 is greater than 20. Okay. I'm checking to make sure I didn't miscopy it. There it is. Now, the absolute value bar is isolated already? Yes. How does this problem differ from the ones we've just done? Like here, this is what's the word? Linear or quadratic? This is linear. There's no x square in it. So how does this problem differ? There's that x square in it. This is quadratic. You still started off the same way. Equal positive, equal negative. So x squared plus 2x minus 28 equals positive 20. And can y'all see this green, or does it not show up? X squared plus 2x minus 28 equals, what am I about to write here? Negative 20. So equal positive, equal negative. Well, how does it differ from the one we just did? Well, that other one was linear, so you just get the x by itself. What are we going to have to do here? Okay, you're going to have to get a 0 and factor. Okay, you move the 20 over. This is how you solve those quadratic equations. You get a 0 and then either factor or use the quadratic formula. This problem factors really nicely. So when I move that 20 over, what are we going to have? An x squared plus 2x. Is that going to be a minus 48 equals 0. I'm subtracting the 20, right? Is that what I would do? Subtract 20. Is that I'm getting minus 48? Y'all caught up with me? Now, instead of just isolating x, this is where we factor, but everyone's is rigged to factor really nicely. Okay? It's going to be pretty easy because there's not that number in front of the x squared. So 1 times 48. What numbers multiply together to give 48? 1 times 48, 2 times 24. 4 and 12 give 48, don't they? There's another pair. Can you think of two other numbers that multiply together to give 48? 6 and 8. Which pair do you think is going to work? The 6 and 8 are the ones you can subtract and get the 2. So let me factor it. X and X. 6 and 8. How should I arrange my plus and minus signs to get a positive 2x? Get a positive 2. I'm thinking that negative on the 6 and plus on the 8. I'm deaf up here in case y'all haven't figured that out. Is that right? Did that do it? If you look at the outer and inner, this would put a negative 6x. If I don't get the right one, then I need to just change the signs. And a plus 8x. Is that giving me a positive 2x? Yeah. So I think I factored it correctly. Now, set each factor to 0. Don't panic. 20 short years will be finished. So I'll move the 6. So I'll get a positive 6 and a negative 8. Positive 6 and a negative 8. Are y'all caught up with me? Are there any questions? Because I'm about to do the same thing over here in green with the equal negative 20. So I would move the 20 over. So that's going to be what? Adding 20. So I'd have an x squared plus 2x. Is that minus 8 equals 0? So x and x. 2 times 4, is that what y'all are thinking? Or 1 times 8? 2 and 4? Whoever the programmer was that wrote this problem, I give that person my respect, because they came up with a good problem. It has some nice steps, but it works out. It doesn't matter what numbers you get. It's going to work out what's nice, something nice and easy to factor both times. Once you go equal positive, equal negative. How should I arrange my signs to get a positive 2x? Negative on the 2 and plus on the 4, like that? Okay. And then set each one of these factors to 0. So we have a lot of cut points here, right? A positive 2, and what's the other cut point? A negative 4. Equal positive, equal negative. Oh, I haven't asked this, so I may as well ask it now. Are we going to have open or closed circles at these 4 cut points? Open, because there's not an equal sign here. So I'll draw my number line. I'm going to put 4 marks. 1, 2, 3, 4. And I'm going to put these numbers in numerical order. So which one would be furthest to the left? Here are the numbers I'm looking at. 6, negative 8, 2, negative 4. So what goes here? Negative 8, and then negative 4, and 2, and 6. Okay. there was a lot of factoring here. Notice there were no repeated factors. So this thing definitely alternates. Everything alternates, but you know, how can I look at them and tell, yeah, they alternate? No repeated factors. So let's see, wow. What number do I want to plug in here? Well, there's only 4 I can't plug in as a test point. And those 4 are -8, -4, 2, or 6. What number do you think I'm going to use? 0 is usually the number I use as a test point. Oh, and where on earth does 0 lie on all these intervals? Well, it's on the one that has it between a negative and a positive. This is where 0 lies. Am I running out of room? So I'm going to plug 0 into that original problem up there. So when I put a 0 here and here, the 0 squared is 0. The 2 times 0 is 0. So we have 0 plus 0 minus 28. That's just a minus 28. Now before you decide between true or false, you have to actually take the absolute value. The absolute value of negative 28 is positive 28. Once I've taken that absolute value, is this a true statement or a false statement? It's true. So, true, false, true, false, true. So let me look. Yeah, that's what I mean by alternating. Just like true, false, true, false, true, false. So let's see. It's going to be negative infinity, comma, negative 8. Hopefully you can tell my infinities from my 8s. Negative 4 to 2. Notice, the crossed out ones are not part of the answer. It's the shaded ones, the true ones, that are the answer. So negative infinity to negative 8, union negative 4 to 2, union 6 to 8. 6 to 8, 6 to infinity. Let me start typing this in. Negative infinity, comma, negative 8, parentheses, union, parentheses, negative 4, comma, 2, close parentheses, union, parentheses, 6, comma, infinity, close parentheses, and check it. Okay. We're not finished. Okay. Now choose the correct graph. Isn't that sort of strange? You would think they would have you do the graph first, wouldn't you? But notice they're using, instead of open and closed circles, they're putting the parentheses and the brackets. So this one doesn't have any brackets, right? Only parentheses. So, oh gosh, which one is it? It's either A or D. It is D. Okay. T. Okay. $11 is just like it, and that's why I have a lecture here, or one of the lecture videos. An example like problem 11, I should have said and 12. I'm not going to do problem 11, but it works out the exact same way. Instead of saying equals 20 and equals negative 20, it's equals 2 and equals negative 2. I chose to do the one that has slightly larger numbers. A word of warning. If you wait until the night it's due to work this and you've forgotten, and you start looking at this view and example, oh wow. They just start going and going. With the cut point method, you only have equal signs. You're working with just equations. You see, just equals. The only time there's ever I use the less than or greater than is right here at the testing. Now, if you're actually going through working with the inequalities, there's a lot of rules you got to be careful about, okay? But look what they're doing, going on. After this, they've gotten up to the factoring part for the first one. Oh, shoot. How to make a good impression. Oh, how do I shut this up? Okay. And then look at what they did on this. I'm convinced the person that's doing this, might not have actually known anything other than the answer. This is like before I started giving multiple choice tests, the students would just write stuff and write until I'm like, okay, I'll give them partial credit for that. I don't know what the heck they're doing. But once they found the first two cut points, they draw a number line and test. And then they start all over. Now this is the second part, the equal negative, drawing a number line. And then they do a little hocus pocus once they've drawn two number lines and pop the answer out. And then once they have this answer, they decide, okay, well, look at this and draw the graph. This might look kind of bad. Okay, when you look at it, oh, wow, that's a long problem. But it's certainly doable. Okay? It's certainly easier than what the view and example looks like. And you can impress tutors with it. If you know how to do this problem and you know a math tutor, ask them to help you with it. Unless they know just how powerful that cut point method is. Just go equal positive, equal negative. Get those cut points, plot on the number line. They're going to come up and just be, pages like that view and example stuff. Okay? Now, 12 is the last one. I think once you hit problem 13, it's just some review. I like to have 15 problems. Heck. Okay, starting with number 13, it's just review of old stuff. Okay? So it's time for us to take our break around 9:45. I think I'll start doing some of the